Hello my dear students. So this is my third video lecture on engineering materials. In my last lecture, we have discussed about modified phase rule and one binary phase diagram, which was of antimony-bismuth phase diagram. So before starting today's lecture, I would like to say about some convention in representation of different phases. So what are the different conventions in representation of phases? So first is we will discuss about liquid. For liquid we shall use L, capital L. Then solid. For solid we can use alpha, beta, gamma. For different solids, different alphabets. Obviously these are Greek alphabets. Now we shall talk about that tie line. So in my previous lecture, I have shown you one diagram, this one, and here you can see this line, a continuous temperature line. This is called tie line. So today we will discuss about this tie line. So what is tie line? An isothermal line through the alloy's position on the phase diagram when it is in a two-phase field intersecting the two adjacent solubility curves is called a tie line. So here in this diagram we have two phases. One is solid phase, which is below this solidus line, and one is liquidus phase, liquid phase, which is above of this liquidus line. So we have two phases, one is liquid phase, another is solid phase. So as per the definition of tie line, we have two different phases, and this tie line is cutting this solidus line and also this liquidus line. Tie line rule. So what is tie line? Just now I told you the definition of tie line. Constant temperature line drawn in two phase region. Constant temperature line drawn in two phase region. So this is the definition of tie line. So now we will talk about that tie line rule. So we have to draw a little diagram for this tie line rule. To know about this tie line rule, So this line, this pink colored line is tie line. Here we have alpha phase and here we have liquid phase, L phase. Here alpha or solid phase. So I already told you that for solid we can use that alpha, beta and gamma. So for solid we have alpha phase in this place, alpha phase region, and here we have liquid phase region. And in this place we have alpha plus liquid. This line is called solidus line and this line is called liquidus line. So before this solidus line we have alpha phase, and after this liquidus line we have liquid phase, and in between we have this alpha plus liquid phase. And here it is a constant temperature line which is parallel to the composition axis and perpendicular to the temperature axis. So this constant temperature line is called tie line. So now we will talk about isomorphous system. So what is isomorphous system? The simplest of binary diagram is an isomorphous system. Simplest of the binary diagram is known as an isomorphous system. An isomorphous system shows complete solubility in both liquid as well as solid states. So what is isomorphous system? Isomorphous system shows complete solubility. Okay, complete solubility in both liquid state as well as in solid state. So we have a number of such system in the nature. For example, copper nickel diagram, AU gold copper diagram, SiG diagram, Al2O3, Cr2O3 phase diagram. So these are the some example of isomorphous system. So now we will draw one isomorphous system and understand the liquidus, solidus, what is liquidus, what is solidus, these things. So I am drawing a copper nickel phase diagram which is a isomorphous system. So we already know that the x-axis is for composition and y-axis for temperature, and the composition axis we have to write them in alphabetic order. So we are discussing about copper and nickel. So copper will be in left side and nickel will be in right side. And in this side we have temperature. So let us say this point is 1083 degree C. 1083 degree C. And here it is 1453 degree C. So here it is 1083 degree C, and this side it is 1453 degree C. So right now we have to draw the solidized line. This one is solidized line and this one is liquidus line. Solidus line and liquidus line. So in this place or in this region we have liquid phase, and here below the solidus line we have alpha phase, and in between this is liquid plus alpha phase. So this is one isomorphous system, which is the simplest of binary diagram, and here copper and liquid both are completely soluble in liquid state as well as in the solid state. So that's why it is called isomorphous system. Here it is weight percent. So I have seen one student have asked me about if this is atomic weight percent, what will be happen. So if this is weight atomic weight percent, this will become isobar or isotope. So that's why we are talking about that weight percent. Now, what is liquidus? Basically, liquidus means locus of temperature points above which the system consists of all liquid. Liquidus line means locus of temperature points. So this is the locus of temperature points above which the system consists of all liquid. So what will be the definition of this solidus line? So this is the locus of temperature points. This is the locus of temperature points below which the system exists as all solid. Below which we have all solids, and above of liquidus line we have all liquid. So this is composition axis. So here if we take this point, so the percentage of copper and nickel will be like 10% of nickel and 90% of copper. But if we take in this position, it may be consist of 80% of nickel and 20% of copper. So in this side, the composition of these two components are differing. Now I shall talk about one phase region. One phase region. So I have to draw one diagram for that, so that you can understand it easily. So here it is composition axis, and temperature axis. In this side it is liquid, and here we have alpha phase, which is one solid phase. So now we will talk about one phase region. So let us say now from the composition, or here we have 0 degree C, and from 0 degree C the temperature is increasing, and we are moving from 0 degree C temperature to, somehow we are moving to, let us say now we are in 500 degree C. So here we have alpha phase, as below this solidus line we have only one phase, that is solid phase, and we are naming this as alpha phase. So in this point, let us say this point is A point. In point A we have alpha phase at temperature 500 degree C. So if we move in this direction rightward and come to this position, this point is, let us say, B. Here also we have alpha phase, and here at temperature, let us say this is temperature 700 degree C, and the point is C. Here also we have only one phase, that is alpha phase. If we go like this and come to point D, here is also we have only one phase, that is alpha phase. So by changing the temperature below this solidus line, we have all alpha phases. That's why this region is called one phase region. And if we take above this liquidus line, we have only liquid phase. So in this place also we have one phase region. So here variable, how much variable do we have? We have two number of variables. One is composition variable, because composition, in this point we have one kind of composition, in A point we have another kind of composition, in B point we have another kind of composition. But if this line is perpendicular to this axis, composition axis, then B and C both will have same composition. But if this line is not perpendicular to the composition axis, these two also will have different composition. So composition, here composition is one variable, and another is temperature. Number one is composition variable, number two is temperature variable. So here in one phase we have two kinds of variables. One is composition variable, another is temperature variable. So for two one phase and two variables, I already have shown you in my previous class. I can show you that table that you can remember this one. So for one phase, variable will be 2. Okay. By using this formula also we can say V is equal to P into C minus 1 plus 1. We have two variables. One is composition, another is temperature. And degree of freedom will be 2. Degree of freedom will be 2 by using this modified phase rule. Here P phase is equal to 1, one phase region, one phase, P is equal to 1. See, number of components, we have two number of components. Here we have two number of components. Let us say this is for copper nickel. So this side copper, this side nickel. So we have two components. So C is equal to 2, P is equal to 1. So by using this formula, F will be 2. So here degree of freedom F is equal to 2. F plus P is equal to C plus 1. We have used this formula to find the degree of freedom, where P is equal to 1 as we are taking one phase region. P is equal to 1, C is equal to 2. So ultimately F will come as, degree of freedom will come as 2. So that's all for today's class. So today we have discussed about Solidus and Liquidus line, one phase region, isomorphous system, Copernican diagram, these things. And in my next lecture we will discuss about two phase region. So thank you for today.